Good afternoon, everyone. We are going to take signals and systems today. Before we start the course on signals and systems, let us try to understand the importance of signals and systems in our course, as well as this course of signal systems will be useful even in communication system also. This is a basic course which helps you in developing your understanding towards signal systems, leading to digital signal processing also. Finally, once you will be pursuing your M.tech or ME in signal processing, this course will be very much useful, and the advanced version of this course will be a compulsory course in your ME course. The basics of signals and systems also will be used in communication system and communication theory also. So let us see what we have to study in this course, and as per the GATE syllabus is concerned, let us see what all things are there. The main course is signals and systems. What we are going to study in this? Let us see. The syllabus which is prescribed in our syllabus book is, the first thing we are going to study in this is signals. The classifications, types of signals, classification, some basic signals. When I say some basic signals means we are going to study about unit step, delta function, ramp function, impulse function. The second thing which we are going to study is about the systems. Again, types of systems. We study about LTI system specifically. Here we will study about convolution, different types of systems, how to identify the types of systems, linear system, time invariant system, causal system, non-causal system, stable, invertible, all those things will be dealt in the systems. And then particularly in the whole course, we will assume that our system is a linear time invariant system, and with that we will do all our complete theory, whether it's a Laplace transform, Fourier transform, or Z transform, any other transform. In that we will assume that my system is LTI. Once we are done with signals, the basics of signals and basics of systems, we will move to the transform theory. And the first transform which comes directly after this is the Laplace transform. Here in Laplace transform, we are going to study the definition of Laplace transform, region of convergence, and properties. Similarly, as the Laplace transform is there, this is for a particular types of system. That means the signal should be continuous time system. The system should be continuous time, or signal should be continuous time. Then we can have a Laplace transform on that. If the signal is discrete time, or if the signal is discrete time, then we can have another transform which is known as Z transform. All the things what we have done in Laplace transform, same thing we have to do in Z transform also. Definition, region of convergence, and the properties of Z transform. There are two transform. Again, we will study in Laplace transform. There is something called unilateral Laplace transform. Unilateral Z transform we will do in this. Okay. So this is one part of the syllabus. Next, we have to see about the frequency domain representation and frequency domain analysis. Okay, I'll write the main heading as the frequency domain representation and analysis. Here comes a very important topic, and that is known as the Fourier theory. And the first part of the Fourier theory is continuous time Fourier series. The second one is discrete time Fourier series. Then we have continuous time Fourier transform. And finally we have discrete time Fourier transform. These four different types of frequency domain analysis, or in part of Fourier theory, they are particular to the different types of the signals. Continuous time Fourier series exists for continuous time periodic signals. Discrete time Fourier series exists for discrete time periodic signal. Continuous time Fourier transform for continuous time non-periodic signal. Discrete time Fourier transform for the discrete time non-periodic signal. Okay, so depending on the types of the signal, these four different types of Fourier analysis is done. Okay. Apart from this, there is another transform which we will see, and that is basically a transform, way of finding the Fourier transform on the hardware, and that is known as a discrete Fourier transform. It is commonly known as DFT. DFT is employed on the hardware, and it is employed using an algorithm known as fast Fourier transform, which we will see when we study the DFT. Okay. So this all these things we have to study in our course. The next thing which is important again for both ECE and electrical student, and that is known as sampling theorem. We want to process a real world signal using a digital hardware. The only way is to first sample it to discrete time, and then quantize it, and then finally process it. So what is the rule of sampling any signal? There is a rule, a well-defined rule, which says that we will see that what that rule is. Using that rule, we will study in sampling theorem, and we'll make sure that if we apply this rule, we can reconstruct my signal back. Okay, that is the thing which we have to study. Apart from this, we also have to study some basics of the filters, digital filters, FIR, IIR, what they mean is. Okay. This is all what we have in our course of signals and systems. Okay. Okay, now to start off with signal first. Okay. Let's start off our course with signals. So the basic thing which came to our mind initially, and when we first wrote the syllabus of the signals, we just wrote what are the different types of signals and what are the different classification of the signals. So how many types of signals can exist? there are basically only 4 types of signals which can exist. The first, let me write here, types of signals. And you will see, you will appreciate this, that yes, there are only basically 4 types. And the classification is something different. The first of the type is continuous time periodic signal. Second is discrete time periodic signal. Third one is continuous time non-periodic signal. Fourth one is discrete time non-periodic signal. Now let me put more stress on this. We just assume any signal in our mind, any signal, whatever we can think, we can put in any of these categories. Whatever I am speaking, that is continuous time non-periodic. Whatever I am speaking, if I able to sample it, that becomes discrete time non-periodic signals. Continuous time periodic, these 2 types of signals rarely exist, but yes, they do have mathematical existence of both these signals. These 2 signals, most of the time they exist, and most of the signals in real world are of continuous time non-periodic or discrete time non-periodic signal. Let me once again, let me say, I have not stated this. Let me say, what is the definition of the signal? Signal is anything, signal which conveys some information which you want to transmit from source to destination, or you want to convey something, that is a signal. If I raise my hand in class and I say that I am present, that is a signal to the teacher that yes, that particular student is present in the class. So that is also a signal. But what we study here is only the mathematical way of analyzing the signal, right? Whole course of signals and systems is completely a mathematical analysis of signals and mathematical analysis of systems by using some tools. Those tools either can be Laplace transform, Z transform, or Fourier theory or Fourier analysis. Okay. So depending on these type of signals, there are Fourier theories also divided into 4 parts. We have studied that just before this we have studied, we came to know that Fourier theory is of 4 types: continuous time Fourier series, discrete time Fourier series, continuous time Fourier transform, discrete time Fourier transform. Now for continuous time periodic signal, there exists a continuous time Fourier series, CTFS. I'll tell you why it happens only for continuous time periodic signal. For discrete time periodic signal, this becomes discrete time Fourier series, DTFS. For continuous time non-periodic signal, that becomes continuous time Fourier transform. And for the discrete time non-periodic signal, that becomes DTFT. So this was once a question in the GATE exam where it was a match the following, the types of the signal and their Fourier series representation. Okay. So you can just see that the Fourier theory says only about the 4 types of transform, 4 types of frequency domain representation. They are according to the types of signals. Right? Now, next thing, this is basically types of the signal. Next we try to understand what are different classification of the signal. Okay. We will do only few important classifications like periodic, non-periodic, power signal, energy signals, even signal, odd signal. We will see what all these things are and how to identify, how to find whether various devices are available which we can put these signals, what is mathematically, electrically generated, and if we analyze them, they can give us some results. There are devices available which can give you the spectrum. Spectrum is nothing but the output of the Fourier transform. And the Fourier transform's magnitude spectrum and the phase spectrum both can come in the spectrum analyzer. Okay. All these things are very fascinating. Once you study your M.tech course and once you see all these things in your real life, you will really appreciate that how this Fourier theory and other things what you are studying in signal systems are actually visible there. Okay. Next, study about the classification of the signal. Important thing. As per the exam is concerned, yes, this is important. Classification of signals. I'll draw 4 different types of waveforms and we just find out how to identify. That is one classification. Okay. The first classification I'll mention in terms of drawing the waveform, and we'll identify when to call a signal as an analog signal and when to call a signal as a digital signal. Okay. One waveform is this. Another waveform is this. Okay, now look at these 4 waveforms and let us identify which one of them is analog, which one of them is digital, which one of them is continuous time, and which one of them is discrete time. So first thing which I want to make clear is when we say the continuous and when we say discrete, I am referring to the x-axis. If I am saying continuous time or discrete time, that means I am referring to the x-axis. Here x-axis is continuous, here x-axis is continuous. Here x-axis is discrete, here also x-axis is discrete. Okay. So one thing which we can readily see from here is these two are continuous time and these two are discrete time. Okay, fine. Next thing about analog and digital. Once I say about analog and once I say about digital, it means about if this we look at the y-axis now, because x-axis is already seen for continuous time and discrete time. So now what we are left with y-axis. Once the y-axis is continuous, that means y-axis can take all the values, infinite number of values. That becomes analog signal. Here y-axis can take all the values. It becomes analog signal. Look at this. Y-axis is taking only finite number of values. One is this, another one is this, another one is this. And then again this one, this one. Finite number of values. That becomes a digital signal. Look at this. Here any value can come. Any value can come here. So again here in this case it is a analog signal. In this case only finite values are there. 1, 2, 3, this all constant values, another this set of values. Only 2 sets are there. Only 2 levels are there. So what we can finally say is, the conclusion is, if the signal is discretized if the signal has got all the time values if the signal is continuous in x-axis, becomes continuous time. If the signal is discrete in x-axis, becomes discrete time. If the signal is continuous in y-axis, becomes analog signal. If the signal is discrete in y-axis, becomes a digital signal. So digital signal definition is not only ones and zeros. Digital signal definition says that if there are finite number of amplitude levels, only finite number of amplitude levels, that becomes a digital signal. Okay. If there are infinite number of amplitude levels, any amplitude can come, that becomes an analog signal. So I can name this as continuous time analog, this signal. I can name this as discrete time analog. I can name this as continuous time digital, and I can name this as discrete time digital. This is fun classification of the signal. That means you are classifying the signal based on whether the analog signal or digital signal. I hope this definition of analog and digital is clear. When I say analog and digital, it is about the y-axis. When I say continuous and discrete, it is about the x-axis. That is a simple rule to remember, nothing more than that. That is one classification. Let's see another classification. The next classification which I have is periodic signal and non-periodic signal. Again, we have to go back to our 10th class mathematics where we studied about the periodic function and non-periodic functions. The same definition of this function is applicable to signal also, because signal in actual they are nothing, just mathematics. And once we study about mathematics, the rule is if any function f of x is periodic, then it is f of x plus t for all x. Very important, for all x. That means your function should exist from minus infinity to plus infinity. All values of x must be there. If the function is existing only for finite duration, that is mathematically it is not a periodic signal. It is not a periodic function. Okay. Similar thing is true for the signal. I can write here a signal x of t. Time is the independent variable. Signal x of t. If it follows this condition, x of t plus capital T for all t, then xt is periodic signal. Here xt is considered to be a continuous time signal. Okay. Definition exists even for discrete time signal also, and that definition is if a signal x of n, now the t is replaced by n because signal is discrete in time. If it is x of n plus capital N for all n, then it is a periodic, discrete time periodic signal. Now there are certain conditions. This n must be an integer, a positive integer. This t can take any real value. This t can take any real value. Okay. Signal should exist for infinite duration of time. That means from minus infinity to plus infinity. It should exist for all t's. Similarly, for discrete time case, signal should exist for all n. From minus infinity to plus infinity, all the values of n must be there. That is the strict sense definition of periodicity. If this condition is followed, signal is periodic. If it is not followed, signal becomes non-periodic. Okay. Let's take some example and see how to identify the period of a given signal, and to identify whether the given signal is periodic or non-periodic. See, examples. Find out the period of cos 2 pi by 5t. Second, sin 2 pi by 3t plus cos 4 pi by 5t. Third, sin 2t plus sin pi t. Okay, let's see the periods of these three different signals and identify whether the given signals are periodic or not. They all are continuous time signals. Okay. To find the period of any trigonometric function, we know that if it is cos omega naught t, then if it is periodic, then this must be equal to cos of omega naught. Let me write it again. Any sinusoidal or cosinusoidal function cos omega naught t. If I want to find the period of this, it is nothing but cos of omega naught t plus capital T, because if it is periodic, it should satisfy this condition. Now I can write this cos of omega naught t plus omega naught into capital T, right? All sinusoidal and cosinusoidal functions repeats after every 2 pi. That means even cos omega naught t must be equal to cos omega naught t plus 2 pi k, where k is an integer. Now you compare this and compare this. You will find that omega naught t is equals to 2 pi k, and t is nothing but 2 pi by omega naught k. K can take all integer values, 1, 2, 3, 4, 5, 6 like this. Now how to find the period of this? What should be the value of k if to identify the t? The value of k must be the least value, and that must be equal to 1. That will be known as the fundamental period. If I put the value of k equal to 2, that is not a fundamental period. If I put value of k equal to 3, that is not a fundamental period. But yes, when I put the value of k equal to 1, that becomes a fundamental period. Now compare this with this equation. Now in this case, omega naught is 2 pi by 5. So in this case, t is nothing but 2 pi upon 2 pi by 5. That becomes 5. That is the period of this signal. Okay. Similarly, we can find the period of this. I hope this thing is clear of finding the period for any, even instead of cos, if it is sine, no issue. It can go ahead like this. This same thing will apply, and whatever the coefficient of t here, 2 pi divided by that coefficient will give you the time period t. Let's see the period of this. Because here, what is happening here, there are two functions. One is this, having a different period. Another one is this, having a different period. Now, how to find the period of both the things simultaneously? Okay. Simultaneously, what is the effect on the total period, the net period of the signal? Let's see that. Let's first find out the period of this 2 pi by 3t. For 2 pi by 3, I'll say let's t1. T1 is nothing but 2 pi upon 2 pi by 3. That gives me 3. This t1 is the period of this part. Cos 4 pi by 5t. Let me write this as t2. That becomes 2 pi upon 4 pi by 5. That becomes 5 by 2. Okay. Now how to find the net period? Take the ratio of t1 by t2, which is equals to m by n. If I want to find the net period is nothing but nt1 equals to mt2. Cross multiply this, cross multiply this. nt1 equal to mt2 will give me the net period. Now let's do in this case. In this case, t1 by t2 will become 3 upon 5 by 2, that becomes 6 by 5. So net period t will be 5t1 or 62. They both will give the same result. Now this is nothing but 5 into t1. t1 is 3, which is equals to 15. From this also, 6 into t2. t2 is 5 by 2. That is again equal to 15. So the period of the complete signal, this whole, is t equal to 50. That is the way to find the period. But yes, again, some catches are there. The ratio of t1 by t2, this ratio t1 by t2 must be a rational number. If it is not a rational number, period cannot be found out. Basically, what we are doing with whole this thing is we are finding the LCM of t1 and t2. Okay? It's up to you. It's up to us how we find the LCM. This is one of the way of finding the LCM, and we are doing that, and the answer of this is 50 in this case. Let's take another problem in which we will see a very interesting thing. This signal is periodic. This signal is periodic. But the combination of this signal and this signal becomes a non-periodic signal. Right? Something which is very interesting. It happens only in case of continuous time signal. In case of discrete time signal, it will not happen. Okay, let's see how it is becoming a non-periodic signal. That means addition of two continuous time periodic signal can lead to a non-periodic signal. Okay. Sin 2t. What is the period of this? Let me write here T1. Omega naught is 2. That becomes 2 pi upon 2 is equal to pi. Yes, this can be the period of this because capital T. Again I will write this. X of t is equal to x of t plus capital T. This t can be a real number. No problem with that. And pi is a real number. So it becomes a period of this signal. And this signal is periodic. Sin pi t. Let me write the T2. That becomes 2 pi upon pi is equal to 2. Okay. Now let's take the ratio of T1 by T2. That becomes pi by 2. Now it is not a rational number because pi is not a rational number. So T1 by T2 becomes an irrational number. Once it becomes an irrational number, you cannot find the period of this. And once you cannot find the period of this, we'll say that yes, it is not a periodic signal. Okay, so that's how this addition of two different periodic signal can lead to a non-periodic signal. It becomes non-periodic. Okay. This was about the continuous time signals. We will see the case next for the discrete time signals. How to find period there. A little complicated, and the unit of the frequency itself, the omega naught unit, is different in case of discrete time and is different in case of continuous time. Okay. Always remember, important point, the addition of two periodic signal, which periodic signal? Continuous time periodic signal can lead to a non-periodic signal. Under the condition, if the ratio of the two periods, if it is not a rational number, then it becomes a non-periodic signal. If it is a rational number, yes, it is always a periodic. Now let's take some example from the discrete time signals. Four numbers. Cos 2 pi by 5n. Cos 5n. Cos 2 pi by 3n plus sine 5 pi by 7n. So we have three problems with us to find the period of this, this and this. Okay. Now again, let us see cos omega naught n. Now here comes very important thing. What is this omega naught? How this omega naught is different from this omega naught? One omega naught is this, one omega naught is this. How to differentiate these two omega naught? This omega naught you will find in many of the books it is written with when the signal is continuous time, and this omega naught you will find in many of the books it is written with signal is discrete time. What is the unit of this omega naught and what is the unit of this omega naught? The unit of this omega naught is radians per seconds, and the unit of this omega naught is radians per samples. Okay, we will see why this unit comes again, but presently just remember that this omega naught and this omega naught are different. This omega naught is a discrete time representing discrete time frequency. This omega naught representing to continuous time frequency. The unit is radians per second, unit is radians per samples. Okay. Now in this case, if cos omega naught n is periodic, then cos omega naught n must be equal to cos omega naught n plus capital N, where n is a period. Yes, If that is the case, then I can write it as cos omega naught n plus omega naught capital N cos omega naught n. Again same thing, all sinusoidal and cosinusoidal function repeats after every 2 pi. So here this becomes cos omega naught n plus omega naught n is equals to cos omega naught n plus 2 pi k. From this it becomes omega naught n is equals to 2 pi k omega naught upon 2 pi is equals to k by n. Now here we have taken in case of continuous time signals that this k should be minimum and that k value must be 1. But in case of discrete time signal, this is not true. Why? Because the condition imposed on the period n. The condition imposed on this n must be an integer value. And till that we have to take that value of k for which this k by n becomes a minimum factored form. That means rational number represented in minimum factorial form. That means if it is 6 by 4, I can write it as 3 by 2. If it is 5 by 4, it cannot be further reduced. So we have to take this. Like this k has to be reduced, k by n has to be reduced to minimum factored form. Let's take the example here. Let's take this example and find out the period according to this. Okay, this k need not be 1, it can take any value. This n is the period of the signal and this n has got the condition that it must be an integer value, positive integer. Omega naught is radians per samples and 2 pi. Let's see this first case, 2 pi by 5 n. What is the period of this? So omega naught is 2 pi by 5. That becomes 2 pi by 5 into 2 pi is equals to k by n. Cancels. So here becomes k by n is equals to 1 by 5. Now 1 by 5 cannot be reduced further. So n in this case becomes equal to 5 directly. Okay. N equal to 5. So 5 is the period of the first signal. Let's take another example, cos 5n. Omega naught n is 5 here. 5 by 2 pi equals to k by n. Now it's again a problem here. This k by n must be a rational number. Okay, this k by n must be a rational number. One more important property which this k by n governs. Now this, since 5 by upon 2 pi is not a rational number, this is not a periodic signal. This is non-periodic. Okay, so there is something which has exception cases and we have to be a little careful about that. We cannot say that n is equal to 2 pi. No, because n cannot be 2 pi. Because if it is 2 pi, it is not an integer. So that's why this condition fails here. This is not a periodic signal. Come to this case. 2 pi by 3n, sin 5 pi by 7n. See, for this case, let me write here n1. n1 is from the same thing what we did earlier. We can say 2 pi by 3 into 2 pi equals to k by n1. From here I will get n1 equals to 3. From this, sin 5 pi by 7. Sin 5 pi by 7, again same thing. 5 pi upon 7 into 2 pi equals to k by n. So k by n, and let me write here n2. K by n2 is corresponding to 5 by 14. Now see, 5 by 14 cannot be reduced further. Okay, so here just n2 is equal to 14. So in this case, n2 becomes 14. If it is 10 by 28, then we can write it as 5 by 14. Now in this case, n2 is 14. To find the overall period of this signal, it's very simple. Just take the LCM of 3 and LCM of 14. LCM of 3 and 14 together. So that becomes 3 and 14 is 42. 42 is the period of this signal. So when we have two signals, we just have to take LCM of n1 and 2. These are few basics of the periodicity to determine whether the given signal is periodic or non-periodic. Okay. Okay. Now we have some question and answer session. Various students from different places were asking few important questions. Let's see one by one all of these questions. The first question was asked by Priyadarshini from Chennai, and she is asking what is the weightage of the signals and systems for instrumentation engineering. Let me tell you the two answers for this. Signals and system for the instrumentation engineering is important course because instrumentation engineers deal with signals. They have to process the signals generated from the transducer, so that becomes an important part for them. From the gate point of view, I will not say that some subjects are very important, some subjects are not important. Give equal importance to all the subjects. That is really helpful to you, because if you at the end you just think that okay, you are not good in this, you can leave that. But if you are studying from the beginning onwards, or right now if you say from now onwards, I'll say especially signal system is important, because there are good number of problems from signal and systems from the instrumentation engineering, which helps a lot to the students of ESE and for electrical students also. If they want to practice, they can take these previous year gate problems of the instrumentation engineering also, especially for signal systems. They are very good problems. And for Priyadarshini, it's a good, if you feel that your signal system is good, you can have a better scope of getting good marks in signal systems, scoring good marks in signal systems. Abhishek from Dhanbad is asking, yes, Hilbert transform will be covered. Hilbert transform will be covered again in communication system, and where it is actually dealt with. In signal systems, in the course of signal system, it is not specifically specified, okay, the Hilbert transform to be there. But yes, this is an important topic for communication also. We will deal with this topic also. Okay, Abhishek? The next question is Saurabh Nigam from Delhi. Is there any symbol for periodic or continuous or other signal? Yes, there are certain books. If you see, if you want to write a continuous time signal, you are writing like this. For periodic and non-periodic signal, there is no signal. If you want to write discrete time signal, you are writing in a square bracket like this. Okay, so that's what I hope means. This is what you want to ask, the symbol for periodic. For periodic signal, non-periodic signal, there is no symbol. Xt can be periodic, it can be non-periodic. Xn can be periodic, it can be non-periodic. Okay. Let me know, Saurabh, if this is what you are expecting as an answer. Rajiv from Delhi is asking, what is the period of the DC signal? It's a very important, very good question. What is the period of the DC signal? There's a lot of confusion all over. See, ideally DC signal is this, extending from minus infinity to plus infinity. Let me write xt equal to a okay. Now just see, Rajiv, if I write xt equals to t plus 0.1 equal to x of t, is it right or not? Tell me this. It is right, because at t, if I am saying it x of 0 plus 0.1, they both have the same value. That means this condition is right. Even if I write x of t plus 0.0001 equal to x of t, this is right or not? This is also right. That means what is the period here? 0.1. What is the period here? 0.0001. And this is true for all t. It is not that it is only for some t it is true. It is true for all t. If I write xt equal to x of t plus 10 to the power 9. Now tell, if this condition is not true, if this is the case, t is extending from minus infinity to plus infinity, and x of t equal to x of t plus 10 to the power 9, this is also true. And if it is true, then what is the period now? Again the question is back, period is 0.1 or 0.0001 or 10 to the power 9. Let me tell you, Rajiv, very clearly, a DC signal can take arbitrary any period. Arbitrary any period. Whatever you want to satisfy, you can take that DC signal, it will take that period. Okay. For example, if I ask you what is the period of this signal, a plus sine 2 pi t. If sine 2 pi t period is nothing but t equals to 2 pi upon 2 pi, that becomes 1. What is the period of this? Arbitrary any period. Now you take anything with 1, the answer is 1. See what DC signal does. DC signal is nothing but it is shifting your waveform. The waveform, if it is only this waveform is there, the average is 0. But once this has become, the average is shifted to some level. Right? So it is nothing but it takes arbitrary any value. Now another thing which comes in this is, what is the frequency of the DC signal? If the DC signal can take arbitrarily any period, it means that it can take arbitrarily any frequency also. No, it is not like that. To define the frequency, there should be some change in the signal. If the changes are 0, the frequency will be 0. Now you see the changes here. Any changes are there? No changes are there. That's why when we will see this, when we take the frequency domain representation of this signal, they present only at 0 frequency. At other frequency, nothing is there. Okay, so that's the point which I want to make clear, that DC signal can take arbitrarily any period, but the frequency of the DC signal is 0. Okay, I hope, Rajiv, this is clear. DC signal generally does nothing, they shift the signal either downward or upward. Okay, if there is a correct DC signal, if someone says this, what is the period of this signal? I'll say mathematically, strictly, this is not a periodic signal. It cannot have any period. It is non-periodic signal, because it is not defined for all t. It is defined only for some range of t from 0 to infinity. What about 0 to minus infinity? It is 0. Okay, so for this case, yes, I'll say it is non-periodic signal. But if it is existing from minus infinity to t, then it is a periodic signal. Then it can take arbitrarily any period. Whatever you want to satisfy, it will take that. Priyadarshini from Chennai, again she is asking, if k by n is equal to 2 pi by 45, then the discrete signal is periodic or not. Priyadarshini, again we are saying the same thing, the ratio of k by n must be a rational number. If it is not a rational number, it is not a periodic signal. Okay, now in this case you are saying it 2 pi or 2 pi by 45. 2 pi by 45 is not a rational number, and if it is not a rational number, it is not a periodic signal. Okay, simple rule. If it is this 2 pi by 45 pi, then it is a rational number, because this becomes 2 by 45 and 2 by 45 is a rational number. In this case, n becomes periodic, signal becomes periodic, and period is 45. Subodh from Chandigarh is asking some name of the book on signals and systems. Subodh, there are many books which are available in the market for signal systems. Let me tell you a few books which I generally refer, and I feel that they are every information given them is correct. One is Signal Systems by Oppenheim, Wilsky and Nawab. I think second edition or third edition, both are available. You can take any one of them. Oppenheim, Wilsky and Nawab, Signals and Systems, only that is a book name. That is one of the good book for signal systems. In this book, except DFT and other things, everything is covered, and everything is well covered. Sometimes most of the students ask, what about sir problems from the signals and systems? The problems, enormous number of problems are given in this book, enormous number of problems, and all are good problems. Let me tell you, all are good problems. So this becomes, this is a good source of problems and good source of theory for understanding signals and systems. Oppenheim, Wilsky and Nawab. There are good number of problems given in our CC material also for signal systems. You can try, you can solve all these materials. There's a good amount of problems from the previous year gate problems. You can do that also. Okay. For DFT, you can have Proakis, the book name is Discrete Time Signal Processing. Proakis. Whatever information is given about DFT and FFT, it is complete. There is no issue with that. Complete information is given about DFT and FFT. These two books must be sufficient for any signal system course. Let me tell you. Extra things are also given in this, but whatever is required for us, that is completely covered in these two books. Sneha from Agra, she is asking what is the period of cos root 3t. I think it is root 3t plus sin t. If it is cos root 3 plus sin t, then it is a periodic, because this becomes like a DC part to this. But if it is cos root 3t plus sin pi t, sin pi t, it becomes a non-periodic signal. Again, the reason is same, because the period of this and the period of this, if you take the ratio of two periods, they are not a rational number, they becomes an irrational number. And once they become an irrational number, it is not a periodic signal. Okay. The ratio of t1 by t2, let the period of this is t1, find out the period of this and find out the period of this. And then you find t1 by t2 and see whether t1 by t2 is rational or irrational. If it is irrational, it is not periodic. If it is rational, yes, the period will exist. And the way to find the period is, it is nothing but t1 by t2 is m by n into t1 plus m into t2. That gives you the period. Okay. I hope this is what you are expecting, right? It is not a periodic signal presently. Okay. Why we are, Manoj from Jodhpur is asking, sir, why we are taking omega 0 equal to 2 pi k? Please explain. Omega 0 equal to 2 pi k. No, I am not taking, Manoj, omega 0 equal to 2 pi k. I am taking omega naught into t equals to 2 pi k. It is not only omega 0, it is omega naught into t equals to 2 pi k. See, definition of periodicity is this: xt equal to x of t plus capital T, right? So I have defined my sinusoidal or cosinusoidal signal as omega naught t, and I am assuming that if it is periodic, then it should satisfy this thing. Okay, if it is periodic, assuming that it is periodic, let's apply this property. This becomes cos omega naught t plus omega naught into capital T, right? Now this is one thing from the definition of the periodicity. Next thing what we can say is omega naught into t, or any sinusoidal or cosinusoidal function that repeats after every 2 pi. You just see, is it not true? Cos omega naught t plus 2 pi is equal to cos omega naught t. Even if I put 2 pi k, where k is an integer, it is same thing again, cos omega naught t. That means this must be equal to this. Now omega naught t is same. Omega naught t must be compared with 2 pi k. That's the reason we are equating cos omega naught t. From this we can find the value of t. Finally, the aim is what? The aim is to find the value of t, right? Sir, can you please define, Unmesh from Pune is asking, sir, can you please define rational and irrational number? Very good, Unmesh. I know many of us will have doubts on this, how to define rational and irrational number. Let's see this, clear this doubt forever. When you represent any number in p by q form, that becomes a rational number where p and q both are integers. Okay, where p and q both are integers. For example, tell me 1 by 3 is rational or irrational? 2 by 3, 3 by 2, 5 by 7. You can see here 1 by 3. One can say that, sir, why it is rational? Because it is not completely divisible. It is coming 0.33333. Always 2 by 3, 0.66666. Always it is like this. Yes, this can be because this is 1.5. This can be because it is something 0. After some decimal place, the same thing repeats. If it is repeating like this, or if it is divisible like this, it becomes a rational number. See, why root 2? You just find the value of root 2. You will get 1.41452719, something like this. This is no repetition here. No repetition of the digits after this. Any next number can come with different value. Okay, so see, what is the dictionary meaning of rational and irrational? Once you say that rational, someone is very rational, he means that someone is very reasonable. There is some reason that why these values are coming always, and they will come like this. There is some reason that why this 0.66666, you know that it will continue to repeat like this only. But in root 2 or pi, these values are not repeating. They are 0.14159276. It goes like this. Okay? So this is what happens if pi, root 2, root 3, they all becomes an irrational number. Okay? And this is a rational number. Right? So we'll start off with our class, and we'll take the remaining doubts in the coming session after we'll complete some more portion. I hope Unmesh, the idea of rational and irrational is clear. It's very simple to analyze. If you can represent any number in p by q form where p and q both are integers, that becomes an irrational number. A very simple definition. P and q, p is an integer, q is also an integer. 3 is an integer, 2 is also an integer. 2 is an integer, 3 is also an integer. 5 by 7, 5 is an integer, 7 is also an integer. Okay? But if they are not integer, becomes irrational numbers. Now we were discussing about the periodic and non-periodic signal. One more good example of periodic and non-periodic signal is which is an exception, and that is find out the period of this mod cos t plus mod sin t. Mod cos t plus mod sin t. What is the period of this signal? Acha. Before finding the period of this, let's first find out what is the period of this. What is the period of sin t? Sin t period, t equals to omega naught is 1 here, 2 pi by 1. This implies t equals to 2 pi. And of course it is. Once you draw the sine waveform, pi, 2 pi, 3 pi, 4 pi, it goes like this, and similarly here also it is present like this. So you can see that after every 2 pi this waveform is repeating. So we say the period is 2 pi. Now tell me, what is the period of sin t mod? Just look at this waveform and tell. Once you do mod sin t, what is happening is positive portion will remain positive, but negative portion will also become positive. Now this waveform will look something like this. Now see what is the period of this. The period of this becomes pi, right? Similar thing happens with mod cos t also. Mod cos t also will have a period of pi only. But now see the exception case. The mod cos t period is pi, mod sin t period is pi, but the addition of these two signals will have a period not pi but pi by 2. Okay, let's see how it is happening. See, again to find that we have to go by the basic rule of periodicity, and that is this. Mod cos of t plus pi by 2 mod sine of t plus pi by 2. What is this equals to? Mod cos of t plus pi by 2 is nothing but mod sine t plus mod sine of t plus pi by 2 is nothing but mod cos t. So again mod sine t plus mod cos t is nothing but equal to mod cos t plus mod sine t, and pi by 2 will satisfy this. So now you can ask me, sir, how to actually find this? See, there are not many exceptions to this. This is only one of the exception. And in such exception cases, if a question comes to identify the period of any given signal, and the exam like GATE exam where 4 options are given, try to choose that minimum value of t, that minimum value among the options which satisfy this condition. X of t must be equal to x of t plus capital T. That is the answer. Finish. Take that minimum value of the minimum value among the options which satisfy this condition. That is the answer. In this case, all the options will be there. Option A will be 2 pi, option B will be pi, option C will be pi by 2, option D will be pi by 4. Now you see, 2 pi will satisfy this, yes. Pi will also satisfy this, yes. Pi by 2 will also satisfy this, but pi by 4 will not satisfy this. So in this case, pi by 2 becomes the answer for this. There are not many exceptions, only few are. This is one of the exceptions. You can go ahead with this like this. Okay? But yes, in this case the answer is pi by 2, not pi. It looks slightly different because the period of this is pi, even for period of this also is pi, but the combination of this becomes pi by 2. Okay. Just a small work which you have to do is, I'll give you one problem. Just go back to your place and go back to your room and find out what is the period of this. Cos pi t square. Okay, find out the period of this. Determine whether the given signal is periodic or non-periodic. If it is non-periodic, no need to find out the period. If it is periodic, then what is the period? Okay, cos pi t square. Find out the period of the signal. Okay. Similarly, you can find even for this also, cos pi n square. Both you can find. Both you can try. Next, the next category of signals we have to see is, they are the important categories, very important, and I hope it may not be very much clear how to define this category of signal, and that is the energy signal and the power signal. The third one. Very easy to understand. Just pay some attention. Energy signal and power signals. Just again go back to your physics we studied in 10th class, and where we find the energy of something. Even in senior secondary course also we did that thing. Suppose a voltage is given and we want to find the power energy of that. What we do? We do V square directly. If current is given, what we do first? We square it. Similarly, any function is given, and if you want to find the energy, if any signal is given, let's say x of t, and if I want to find energy of this, first thing that comes to my mind is, I'll first square it. If it is a continuous time function, I'll integrate it. I'll integrate from the range where the x of t exists. Let's say from minus t1 to t2, or say t1 to t2. And I do this integral. That means if a signal is existing like this, then if I want to find the energy of this, then let the signal be x of t, then I'll use this relationship to find the energy of the given signal. Fine. One is this thing. But signal is not always like this. Signal can extend from minus infinity to plus infinity. Then what to do? This range will become minus infinity to plus infinity. Simple. Nothing else. Change this range from minus infinity to plus infinity. You can again find the energy of that signal. What happens if the signal energy is infinite? For example, let's take an example. Same example, cos omega naught t. Okay, let's find out the energy of this. This waveform I'll draw like this. At t equal to 0 it is maximum, and then this waveform is. Now to find the energy, let this be your x of t. To find the energy, first thing what we are doing is, we are squaring it. Once I am squaring it, what will happen? Positive term will remain positive, but negative will also become positive. Okay, so everything is positive now. In that case, this waveform will look something like this. This is your x square of t. Everything is positive. Nothing is negative here. Now, once I integrate this waveform, since the signal is present from duration minus infinity to plus infinity, minus infinity to infinity, x square t dt. You tell me, what could be the answer for this? Just think, the area of this, let's say the area of this figure is A. Like this, there are infinite figures, both on the right hand side and the left hand side. The value of this integral becomes infinite. Right or not? And if the value of this integral is infinity, I will say that it is not an energy signal. The only simple reason is, if I'm not able to quantify something, I will not consider that at all. If I'm able to quantify something, that means if I have some finite value for this, I will say yes, it is an energy signal. But if the finite value does not exist, infinite value exists, that means the net area of this, the net calculation of this becomes infinity, it is not an energy signal. Okay, that is the first thing. Then you can ask me, sir, when can you say that signal is an energy signal? Very simple. The signal is an energy signal. Let's take another example. Xt equals to e to the power minus at. T greater than equal to 0, 0 for t less than 0. See this signal. Instead of a, I'll write only minus t. That is better. Now you see, this signal looks something like this. Right? Now you apply the formula for the energy signal. From where the signal is existing? From 0 to infinity. 0 to infinity, e to the power minus t whole square dt. What is the value of this? E to the power minus 2t integral 0 to infinity dt, that becomes 1 by 2. Is it not finite? It is finite. And once it is finite, this is an energy signal. In this case, in the previous case, this integral was completely infinity. It is not an energy signal. And now it is an energy signal. Okay, now see this. I'll just modify it. I'll write e to the power minus t minus infinity t infinity. Tell me, this is energy signal or not? Let's talk about power signal later, but see now whether the given signal is energy or not. Now let me draw it first. If I draw this waveform from minus infinity to infinity, it will look, when the t values are negative, when the value of t is negative, e to the power minus t will become positive. And this waveform will look something like this. At t equal to 0 it is 1, and it is going like this. Now one thing automatically we can see is, if the area is under this curve is infinite, the area square is also going to become infinite. Okay, so in this case, if I apply the formula and see minus infinity to infinity, e to the power minus t whole square dt, that becomes e to the power minus 2t minus infinity to infinity dt, that becomes e to the power minus 2t upon minus 2 minus infinity to infinity. Once you put infinity in this, that becomes 0, but when you put minus infinity in this, that becomes infinite. And once it becomes infinite, energy is again infinite, something which is not quantifiable, and if it is not quantifiable, it is not an energy signal. See how important the limit plays the role. If this limit is minus infinity to infinity, it is not an energy signal. But if the limit is existing from 0 to infinity, it is an energy signal. Because when the limit is existing from 0 to infinity, the area under this is finite. But when it is existing from minus infinity to infinity, you see what will happen? It will go like this. And see the net area. It becomes infinite. And if area is infinite, and it is not an energy signal. Okay? So the simple definition of energy signal is mathematically is defined. I hope you have understood with this. Any doubts you can ask me in the question answer session, which we have after every 45 minutes of a lecture. Let me define the energy signal. Signal xt is energy signal, then it should satisfy this condition. It should not be 0 also. If it is 0, then the condition violates. That means nothing is there. Okay. Sometimes I say that if signal xt is a complex signal, then I'll write this as infinity to infinity xt mod whole square dt should be less than infinity. If this condition is found, it is an energy signal. If this condition does not meet, it becomes a non-energy signal. But yes, if it is not an energy signal, it can be something else, and that something else is nothing but a power signal. Okay. But there are chances that signal is neither energy signal nor power signal. It is none of these, neither energy nor power. But it is always true condition that signal can neither be both. Either it will be energy signal or it will be power signal. It cannot be both at a time. Now let's see the definition of the power signal and see how to define that. Power signal. How we find the power? Power, by going back to the physics, we say that power is nothing but energy divided by the total time, right? Energy divided by the total time. Now in this case, when I want to find the power signal, the condition is if xt is a power signal, then limit t tends to infinity 1 over t minus t by 2 to t by 2 This is the definition of the power signal. If xt is complex, then instead of directly writing square it, you have to take the magnitude square. If xt is complex, then you can write here as minus t by 2 to t by 2 1 over t limit t tending to infinity xt whole square dt less than infinity greater than 0. Okay. Now take the first case where we found the energy of the first signal, that simple signal what we had drawn. Simple signal is this. Find out the power of the signal. This is x of t becomes t1 becomes t2. Okay. To find the power, we have to put this signal xt in this relationship, and once we substitute this in this, what I will get? Limit t tending to infinity 1 over t. Signal is existing from duration t1 to t2. t1 to t2 x square t dt. Now tell me, what is the value of this integral? The value of this integral is some finite value. Accept it, because the area under this is finite, so everything when I want to even if I square this, it will remain finite. Area of this integral, the value of this integral will also finite. Okay, but what is t here? Infinite. So what is the power now? Finite upon infinite, that gives you answer 0. That means the power of the signal is 0. The power of the signal is 0. What was this signal? This signal was energy signal. It satisfies the condition of the energy signal, but it does not satisfy the condition of the power signal. For power signal, this becomes 0, and once it is 0, it is not a power signal. Okay, so both the things are complementary of each other. If the signal is an energy signal, it cannot be power signal. If the signal is a power signal, it cannot be an energy signal. Simultaneously, any signal cannot satisfy both the things. That means it is both power as well as energy, not possible. But signal is neither power nor energy is possible. We will take that example. But yes, of course, this is not a power signal. But what are the power signals? Let's see that. What are the power signals? Okay. xt equals to a cos omega naught t. Let's find out the power of this signal. Okay. Minus a. What are these values? What is period of this? T is nothing but 2 pi by omega naught. So this value is 2 pi by omega naught. This value is pi by omega naught. Like this it goes on. Minus pi by omega naught minus 2 pi by omega naught. It goes on like this. Now we have to do one thing, that we have the formula 1 over t minus t by 2 to t by 2. What is the period t here? The period t is finite, right? It is not infinite here. Once it is finite, that becomes 1 over t minus t by 2 a square cos square omega naught t dt. Cos square omega naught t can be written as 1 plus cos 2 omega naught t by 2. So I can write this as minus t by 2 to t by 2 a square outside 1 plus cos 2 omega naught t by 2 dt, and this is 1 over t. So this integral can be split into two parts. A square by 2 1 over t minus t by 2 to t by 2 dt plus a square by 2t minus t by 2 to t by 2 cos 2 omega naught t dt. What is the value of this integral? The value of this integral is a square by 2. What is the value of this integral? See, it is very simple to find out. No need to do is sine 2 omega naught t by 2 omega naught and then putting this limit. Remember, you are finding the net area under this cos 2 omega naught t curve. Okay, the net positive area is equal to net negative area. So they both area cancels each other. The value of this integral becomes 0. Within a period whose DC value is 0, if I find the net area under this curve and this curve, they both cancels each other. The net area of this is something, the net area of this is something, both areas are equal and opposite in sign, cancels each other. Right? So the value of this integral becomes 0 and the power of the signal is a square by 2. And this power is finite. And since it is finite, it is a power signal, not an energy signal. So cos omega naught t, sin omega naught t, all periodic signals can be power signal but not energy signal. Remember this thing. All periodic signals can be power signal but not energy signals. All non-periodic signal can be energy signal. All non-periodic signal can be energy signal. When I say can be energy signal, it means that all non-periodic signals are not energy signals, but all non-periodic signals, all energy signals are non-periodic signals. Okay, let me write all these statement and see whether there is any contradictions to this. The first statement that I made is a signal cannot be both energy as well as power. Okay, it cannot be both energy as well as power signal. Second is a signal can be neither energy nor power signal. This is a second statement. See, already we have seen an example. Xt equals to e to the power minus t less than infinity minus infinity. Is it energy signal? It is not energy signal because energy becomes infinite here. Is it a power signal? No, it is not a power signal because it is not periodic. We have seen an example of cos omega naught t. Cos omega naught t was a periodic signal. In that case, we can find the power of that, and that power is a square by 2. But in this case, it is not a periodic signal, so condition is ruled out. It cannot be power signal. Okay. So in this case, it is neither energy nor power signal. Both the things are there. Third statement. A signal with finite energy will have zero power. A signal with finite energy will have zero power. We have taken an example of this. T1, T2. What was the power of the signal? This is your x of t. The power of the signal was 0. Right or not? Because once we find the power, the denominator term t is infinity. And the value of the integral is finite. So finite upon infinite is 0. So this is a third statement. A signal with finite energy will have zero power. The fourth statement. A signal with finite power will have infinite energy. A signal with finite power will have infinite energy. We have taken an example of cos omega naught t. Cos omega naught t is a periodic signal. And since it is a periodic signal, we found the period of this. It was a cos omega naught t. And then the power of the signal is a square by 2. But what about the energy of the signal? We already seen the first figure what I have drawn. The energy of the signal is infinite because there are infinite number of areas which has to be added. Okay, and once there is infinite number of areas to be added, it becomes an infinite energy or not an energy signal. It is only a power signal. So another statement apart from this is, if the signal is a non-periodic signal, then it can be an energy signal. Remember, it can be. It will not be. It is not that it must be an energy signal. It can be an energy signal. If it is periodic, then it cannot be energy signal. Remember, if it is periodic, then it cannot be energy signal. But if it is non-periodic, then it can be energy signal. Okay. Sixth statement. If a signal is periodic, then it can be a power signal. Again, remember, if the signal is periodic, then it can be power signal. Doesn't mean that if it is periodic, then it should be a power signal. The condition is the limit, that the value of that particular relationship, limit t tends to infinity, 1 upon t minus t by 2 to t by 2 x square t dt, that must be finite. Then only it will be a power signal, otherwise not. Okay. So these are the 6 statements which we can identify, which helps us in identifying whether the given signal is an energy signal or power signal. So a signal is given to you x of t. For that x of t, you find x square of t. You first find whether the given signal is periodic or non-periodic. If it is non-periodic, then it can be energy signal. If it is periodic, then it can be power signal. Okay. Once you came to know that yes, it is a non-periodic signal, then you can go ahead by the formula for finding the energy and see whether the energy is coming finite or infinite. If the energy is finite, yes, it is an energy signal. If the energy is infinite, it is not an energy signal. Okay. If the signal is found to be periodic, then you can say that it cannot be an energy signal. It can only be a power signal. So once it is a power signal, apply the relationship of finding the power of a signal, limit t tends to infinity 1 over t minus t by 2 to t by 2 x square t dt. and get whether the value of this whole limit and whole integral is finite. If it is finite, it is power signal. If it is not finite, it becomes not a power signal. So in that case, signal is neither power nor energy signal. Okay. Okay. Next different types of different classification of the signal that we have to see is the even signal and the odd signal. Let's see what are the even signal and odd signal. Again, whatever we are doing here, all the things we have done earlier in our basic mathematics course of class 10th. Okay, there also we study about even function and odd functions. Here also same thing, even signal and odd signal. They also satisfy the property of even function and odd functions. See, why all these things we want to know is even signal, odd signals, because all these things will help us in determining helping the Fourier analysis, in doing the Fourier analysis easily. Because once we know that signal is even signal, odd signal, there are certain symmetry properties which we can find the Fourier transform very easily. And if options are there given, that becomes a much easier job. Even signals and odd signals. Simple definition: if there is a signal x of t, if it is equal to x of minus t, then signal is even. There is a signal x of t, if it is equal to minus x of minus t, then signal is odd. All the signals, whatever we see, are comprised both even part as well as odd part. That means I can write any signal x of t is nothing but a composition of x even of t plus x odd of t. All the signals. Let's take an example of natural numbers. All the natural numbers are comprising both even natural numbers plus odd natural numbers, right? All the numbers will have even numbers as well as odd numbers. Similarly, all the signals can be decomposed into even part as well as odd part. Okay. For example, if I write xt equal to cos t plus tq plus t plus 1. Now from this, if I want to determine what is the even part of this and what is the odd part of this. So you know cos t is an even part and 1 is an even part, because t cube, if you substitute by minus t cube, it becomes minus t cube. Okay, so this becomes an odd part. T replaced by minus t is an odd part. Cos t replaced by cos of minus t is nothing but equal to cos t only. So this condition is satisfied. Cos of minus t is equal to cos t. So that becomes an even signal. 1 is of course a DC value, it's an even signal. So if I write from here x even of t for this our problem, it becomes cos t plus 1 is even part. And if I write odd part, that becomes t cube plus t. Finish. That's very simple example to understand. There is a possibility that signal contain only even part, there is no odd part. There is an also possibility that signal contains only odd part, no even part, right? And there is a possibility that signal contains both odd part as well as even part. Both the parts can exist. Now we were here. A signal can be decomposed into two parts, x even of t plus x odd of t. Okay, if that is the case, then I can write x of minus t is equal to x e of minus t plus x odd of minus t. If that is the case, I can write x of minus t, x e of minus t is nothing but equal to x e of t only. X odd of minus t is nothing but minus x odd of t. is this relationship. If it is an odd part, x of minus t is nothing but minus x odd of t. Now you have two equations, equation 1, and this is another equation, equation number 2. Two equations, two unknowns. Okay, from this I will get x e1 of t is nothing but x of t plus x of minus t divided by 2. What you can do is you can add these two equations. Once you add these two equations, x naught t and x naught t will get cancelled. 2xe of t is nothing but equal to xt plus x of minus t. That becomes this. Similarly, x odd of t is xt minus x of minus t divided by 2. So if any signal x of t is given to you, then just apply this relationship. Just apply this relationship. You will get the even part and odd part. Okay. Now I didn't tell you that what is this x of minus t represents in signals. It is nothing but a time reversal property. You have a signal which is from, let's say, from 0 to t, extending from 0 to t. Once you do x of minus t, that limit becomes reversed. It becomes 0 to minus infinity. Okay, instead of 0 to infinity, it becomes 0 to minus infinity. For example, see this. If you have this signal, okay, it is x of t, and I want to find x of minus t. What we have to do is we have to consider y-axis as a mirror. We have to consider y-axis as a mirror, and we have to revert it. Okay, so this becomes minus 2 to minus 1, 1. That is x of minus t. This is nothing but time reversal. This is known as time reversal. Okay, let's take some example for even signal and odd signal, how to find few of them. Similar property holds true for discrete time signal also. That in the case of power signal, energy signal, the energy concept is same. For discrete time signal that we missed, let me write it for the discrete time case. Energy is nothing but summation n tending to minus infinity to infinity x of n whole square. This is for energy less than infinity, greater than 0. For power, 1 over 2n plus 1 summation n equals to minus n to n, limit n tends to infinity, x square of n less than infinity, greater than 0. Okay. See this 1 upon 2n plus 1, why we have, so you can ask me, sir, why not 1 upon n just? Okay, you can take 1 upon n, then you have to do minus n by 2 to n by 2. Probably if n is not divisible by 2, it is a problem. So what you can do, you take the limit from minus n to n, you just count from here, minus n to plus n, 2n plus 1 numbers are there. So that's why we are divided by 2n plus 1. If n is divisible by 2, yes, I can write this also. 1 over n, summation n equals to minus n by 2 minus 1, x square n. But you don't know, n can be a multiple of 2, it cannot be a multiple of 2. In that case, better to write this way. That's why in most of the books it is written like this only. Okay. Let's take a break for 5 minutes and then we'll start off with question and answer session. Welcome back again. We have to take a question answer sessions from different places which is coming across. Gautam from Hyderabad is asking, can we treat pi as 22 by 7? Yes, in most of the cases, if you see in mathematics, 22 by 7 is considered as a representation for pi, but this is an approximation. It is not the actual value of pi. You can just see the 22 by 7. If you find, you will find that after some places of decimal, 3 point something, the particular set of decimal get repeat, and if it is repeating, it is a rational number. So 22 by 7 is a rational number, but it is not equal to the real definition of pi. Okay, so pi is actually a irrational number, right? But 22 by 7 is a rational number. But if it is given in the question as pi 2 pi t, then we have to treat as pi, and if it is pi, it has to be irrational. Vikas from Bangalore is asking again, we have already taken Vikas, it is mod sin t plus mod cos t. I said both pi and pi by 2 will represent a period. Even 2 pi will also satisfy this. Not only pi and pi by 2. 2 pi will also satisfy this. Even 3 pi by 2 will also satisfy this. The condition of the period is, if it is asked in the question, that means he is asking for the minimum value of t, and that minimum value of t here is pi by 2. So that becomes the period of this function is pi by 2. Okay. When I write xt equal to x of t plus capital T, it means that it is also equal to x of t plus 2t. It means that it is also equal to x of t plus 3t. We have to consider the minimum value. Okay, so that minimum value is t, and that minimum value in this case is pi by 2. Naveen from Nainital is asking the same thing. I hope, Naveen, I have answered this. The answer is pi by 2, and we have already seen this, why this is pi by 2. If you substitute among the given options is pi by 2, of course the period of this is pi and individual period of this is pi. So if you take the ratio of pi and pi, you will get pi only. Deepak from Faridabad is asking, I have Simon Haken is a good book. Of course, it is no doubt about that. But as per the problems and other things are concerned, you can always see, of course, as per the concepts and other things are given, Simon Haken is sufficient. But the clarity and the things which is treated way, Signal Systems OpenHIM is, I feel that is the best. So defining a book which is good or bad, it's a very subjective thing. Deepak from Faridabad is asking, does LCM of irrational number and rational number exist? No, Deepak, it does not exist, and therefore the period does not exist. Because if one is rational and another one is irrational, you cannot find T1 by T2 which is rational. So in that case, period will not exist. Monica, you are asking the same thing which has been asked earlier. 22 by 7 is an approximate representation of pi, but it is not actually equal to pi. Cos pi t is non-periodic. Yes, Deepak, you are right. It is non-periodic. I have already given to many students this thing. You can solve it. I will tell you later why it is. So if you have got the answer why it is not periodic, it's fine. Otherwise, I will tell you. I will tell you by tomorrow or by in the next class. Please explain how again the period of mod sin t or mod is pi, not 2 pi. See, Monica, just see once again. You have sin t, the period of this t equals to 2 pi by 1, which is implies t equals to 2 pi, right? Now this is okay. Now look at this waveform. This waveform looks something like this. Right? Now if looking at this waveform, tell me when this is going to repeat after 2 pi. So in this case sin t is 2 pi. Okay, that is understood. But once if I take the mod of this, then what will happen? Whatever positive terms are there, they will remain positive. But whatever negative terms are there, they will also become positive. So this waveform will look something like this. Now see, Monica. This is pi, this is 2 pi, this is 3 pi. After what time it is getting repeated? It is repeating after every pi. So that's why the period of this mod sin t or mod cos t is pi, but not 2 pi. Again, by using the mathematical relationship, you cannot find out, right? But by looking at the waveform, you can easily see it. Priyadarshini from Chennai is asking, what is the significance of power and energy signal in real time? Real time, whatever signal they exist, they all are energy signals. It is only a mathematical descriptions to define, to classify the signals in two types, which is power signal and energy signal. In real time, there is no such significance. Of course, in real time, all signals are energy signals, not power signals. Why? Because in real time all signals are non-periodic in nature, and once they are non-periodic in nature, they cannot be power signals. Janani R from Chennai is asking how to find energy signal. Please explain with an example. Okay, Janani, see this. I'll take one more example. You have this signal. E to the power minus t by 2. Okay, let's find out the energy of this signal. So this signal is existing from -1 to infinity. Okay, from -1 to 0 the value is constant 2, and from 0 to infinity value is governed by this curve equation, which is 2 e to the power minus t by 2. So I can write here as -1 to 0, it is 2 square dt plus, what is the energy relationship? Minus infinity to infinity x square t dt. So instead of xt between -1 and 0 is 2, so 2 square dt. From 0 to infinity, it is 2 e to the power minus t by 2 whole square dt. If it is right, just solve these two things. You will get 4. That becomes 4 plus. This becomes 4 e to the power minus t. 0 to infinity. That becomes 4 plus 4, 8. That is the answer. Okay. For any signal xt is given to you, you just apply this relationship and see whether from what range the signal is existing. It may exist from 0 to infinity, it can exist from minus infinity to 0, it can exist even from minus infinity to plus infinity. Apply this, solve that integral, get the answer. That's a simple thing. Revati from Erode is asking, sir, in last condition you wrote for power, could you please explain the condition again? In that, what is h? No, it is not h, it is n. It is because once the signal is discrete time, when the signal becomes discrete in time, I have to represent it by discrete number or discrete index n. Okay, so that summation whatever is there, that comprises of n minus infinity to plus infinity. This is for energy signal. Okay, and for power signal, n equals to minus n to plus n x square n 1 over 2n plus 1, limit n tends to infinity. Why we are, Priyadarshini from Chennai, she is asking why we are taking integral from minus t by 2 to plus t by 2 in power signal, general formula, instead of t1 to t2. Is there any specific reason? See Priyadarshini, okay, let me, if I ask you one thing, what is the period of a non-periodic signal? Then what is your answer? If I say this signal is this, what is the period of the signal? xt, extending from 0 to, let's say, t. The period of non-periodic signal is infinite. Why? Because I will say that this thing will repeat after t equal to infinity. Or let me write this t1. This thing will repeat after t equal to infinity. Now mathematically, no one is there who can go to infinity and see whether it is repeating or not. So I can say that yes, it will be there, but at after t equal to infinity, just go and see whether it is existing there or not. So I can say, to ease my, what you can say, mathematically to prove something, or mathematically if I want to have to prove my derivations and other things, I can assume that the period of a non-periodic signal is infinity. Now coming to your this thing, why we are taking integral from minus t by 2 in power signal general formula instead of t1 to t2? See what I have taken limit here, limit t is tending to infinity, 1 over t minus t by 2 to t by 2 x square t dt. Right? If you are saying that I can take from t1 to t2, yes I can take, but now see what will happen. t1 to t2 x square t dt. Now what is the range the signal is existing? t2 minus t1. So I have to divide this by T2 minus T1, and now this T2 minus T1 should be tends to infinity. That means signal should exist for infinite duration of time. Once it is existing for infinite duration of time, then only this condition is true. See what I told first, signal should be periodic. If signal is periodic, it means that it should exist from all values of t, from minus infinity to plus infinity. That's why writing this is much easier than writing this. Okay, that's why we are in most of the books it is written like this instead of this. Okay. Swati from Delhi is asking, what is the period of cos 5 3t plus I think there is some period of cos root 5 3t plus 90. Swati, you can please what is this power? Acha, cos to the power 5. Okay. Cos to the power, is this you want to know? Cos to the power 5 3t plus 90. Use trigonometry first, remove this power term, explain into some individual terms and get the overall period. That is the only way to find out. So for example, if I ask what is the period of cos square 3t, in this case let's find out, because this is easier and this is same to this. Cos square 3t I can write it as 1 plus cos 6t divided by 2. And if it is this, I can write it 1 by 2 plus 1 by 2 cos 6t. Period of this is a DC signal, it can take arbitrary any period. Period of this is 2 pi by 6, that becomes pi by 3. So overall period of this t, what is the power of this signal? A square by 2. Again, if you want to see why the energy is infinite, let's draw this signal. This signal is drawn like this. Okay. Now if we see, this is your x of t. Once you find the energy of this, what you have to do? You have to find x square of t first. Once you find the x square of t, what will happen? This negative term will also become positive and this will get square. So they will appear something like this. Okay. Extending from minus infinity to plus infinity. Now you are integrating this minus infinity to infinity x square t dt. Otherwise, if you want to see directly mathematically how it is happening, you can just see this. Minus infinity to infinity, a square cos square omega naught t. Expand this. Minus infinity to infinity, a square by 2 dt plus minus infinity to infinity, a square by 2 cos 2 omega naught t. What is the value of this integral? Infinite. And infinite plus something is infinite. So this integral energy becomes infinite. How mod of sin t becomes pi? Please explain. Saroj, we have already seen this. You just draw the waveform of sin t and draw the waveform of mod of sin t. It is nothing but an output of a full wave rectifier. And this full wave rectifier, if you see, the frequency gets doubles, right? And from 50 Hz it becomes 100 Hz. You can see the period will become half. UN is a periodic signal or a DC signal? Because the power of it is 0.5. Does that mean that it is a periodic? Vikas, let me tell you, UN is neither periodic, it is not a periodic signal. And if you are thinking that the power of UN is 0.5, it is not right, because UN or UT, unit step or unit step signals are neither power signals nor energy signals. We will clear this when we will study the unit step signal. Priyadarshini from Chennai, whether the last two statement, the periodic signal must not be energy signal? Yes. And non-periodic signal must not be a power signal? Yes. That is true. It definitely implies that. Swati from Mumbai is asking how to identify whether the signal is periodic or non-periodic. Swati, the very basic definition of periodicity and non-periodicity we cannot find period of mod sin t method but by seeing the graph. That's the only way. That's the only way we have to look into this. Otherwise, once we look at the graph and we can see that, okay, in the graph it is repeating after every half period instead of full period of 2 pi, we can find out. See, Monica, there are very few exceptions to this, not much. And once you do the modulus, the period will always become half. Remember this. Once you do the modulus, the period will always become half. What is the energy and power of a RAM signal? Rohit, RAM signal is neither energy signal nor power signal. Okay, so we cannot find the energy as well as power, because again, look at this graph of the RAM signal, how it looks. See, Rohit, the energy and the power of a RAM signal. RAM signal looks something like this. Okay, let this be your x of t. Let's find out the energy of this. 0 to infinity, this is t, becomes t square dt. That becomes t cube by 3. 0 to infinity, that becomes infinity. So what is it an energy signal? It is not an energy signal. Okay. Next, coming to the power. 1 over t. Of course, for finding the power, we need not to do anything because it is not a periodic signal. So need not to do all this kind of things in this, and we'll say that it is not a power signal. Okay. So energy signal, the RAM signal is neither power nor energy signal. For signal to a power signal, it has to be first periodic. If it is not periodic, forget about the power signal. A simple case. You can see this, I can sure that you will meet this statement across all the problems without any exceptions. That's why sometimes the student makes a mistake that they say that ut is a power signal and the power of this is finite. No, that is not true. Ut is neither power nor energy signal. We'll take a break for 15 minutes and then we'll resume our class at 4:15 again.